All right, hey there, guys. So, hey, for this day of notes, what I'm going to do is I'm just going to go ahead and um, work through the problems from yesterday or from the previous day, so that you guys can sort of see what those problems are. Look what the answers look like. There are some problems in here that there are some very similar types in the actual PFA. So, hopefully this is helpful, and hopefully maybe it might create some questions that you guys have. Okay, so this first one, it gives me some information. It says in the diagram, A equals 2 and B equals 3. Let's go ahead and label those. I think that's just going to make life easier for us. Now, in here it says, for what values of C and D would the rectangles be similar? Now, remember that similar means two things, okay? Similar means same angles, and it means proportional sides. Proportional sides. Okay, well, I know I've got the same angles. And I know that because it said rectangles, and rectangles have all 90-degree angles. So I don't need to worry about the angles. What I really need to think about is the proportional sides. So what does proportional mean? Well, proportional basically means we can make the same fractions out of corresponding sides. So I'm going to go ahead and just mark my corresponding sides, okay? A and C both look like they're the short sides here, so that isn't always the case. We can't always count on looks, and we'll see that in an upcoming problem. But for now, let's just go ahead and say A and C correspond, B and D correspond. So there's two ways to go about this. One way is that you could make a separate set of fractions for each one of these. So you could do like yellow divided by yellow and then blue divided by blue for each one of those. I think it's going to be faster if we actually make a fraction for this rectangle, and then we make fractions for each of these and compare them. I think we'll have to do fewer fractions then, and that'll go a little bit faster. So let's do that. Oh man, sorry guys, I can't hit the right button. It's this little bitty button, so small. All right, so let's erase this thing about proportional angles. So we have some space, or sorry, proportional sides. All right, so first let's go yellow divided by blue. So that's going to be 2 divided by 3. And that is going to be 0.66. I just know that off the top of my head. We're going to put some stuff in the calculator in a second. Don't be afraid to use calculators, okay? So we want the one that's the same as that. So let's go ahead and, by the way, C is yellow, so I'm just going to do yellows for all these. And then I'm going to do blues for all these, just so I keep it straight. So we did yellow divided by blue. So that's going to be 6 divided by 2, 1.2 divided by 1.9. I'm just grabbing these guys. 6 divided by 2, yellow divided by blue. 1.2 divided by 1.9. 4 divided by 6, that's this. And then 2.2 divided by 3.2. Okay, so let's go ahead and open up the calculator. All right. So I've got 6 divided by 2, and that is 3. I've got 1.2 divided by 1.9, and that is, oh man, look at that, 0.63. I've got 4 divided by 6. 4 divided by 6 equals 0.66. It really should be 0.6 here, 0.667. We'll add that. And then 2.2 divided by 3.2. 2.2 divided by 3.2. And that's 0.69. Now, remember, we're comparing to this one, and we see that it matches with this one. So 4 and 6. That's my correct answer because it makes the same fractions, okay? That means the sides are proportional. We'll write that in like proportional. All right. Now let's look at this one. Which statement is true? I want to zoom in on this. If MNP, holy cow, what was that, you guys? If MNP, and you see this symbol, that means similar to. All right, so if M and P is similar to X, Y, Z. So remember, similar means a couple things. Similar means that for one, I have the same angles. For two, I have proportional sides. Let's also remember that um, similarity is a result of dilation. So I'm going to draw these as if they've been dilated. So let's make that M in P, but now let's imagine a dilated version. In fact, actually, I could probably just do that, right? So let's just, oh my gosh, I made them all different. Well, this is just silly. What are we doing, guys? Copy? Make me another one? Oh, cool. All right, so we make that bigger. Oh yeah, that's exactly what I wanted to do. I wasn't sure I was going to do it. We'll get rid of, oh wait, yeah, there we go. Get out of here, M. Where's my little button? There it is. Get out of here, N and P. All right, so now this is X, Y, Z. Okay, well, we know that because it's similar, we know all the angles are the same. So P and Z are the same. M and X are the same, and N and Y are the same. Okay, all we know about the sides is that they are proportional, so they're multiplied by the same number. I don't know anything else. They're certainly not congruent just because it's similar. So let's go and look. So this first one says right here that says that M and P and X Y Z have equal perimeters. Well, that would mean that to measure around the outside of each one would be the same measurement. And I think it seems obvious that that's not true because XYZ is bigger, so it's farther around the outside. So that's not true for similarity. Now, the second one says that the two have equal areas. So this one says equal areas. Well, if we think about that, that means that the space inside of the triangles are the same. And that is certainly not true because, again, XYZ is bigger. So the space inside just can't be the same. So that is also not true for similarity. Let's go ahead and you might see this coming, but let's skip down to this one. So corresponding sides are always congruent. So that would mean that like MP and XZ are the same length. Well, and that's clearly not true because again, they're not the same size. So all three of these ones that we've marked off, they depend on the sides, the lengths of the sides. The side lengths are not the same. Now, this one that we left only talks about angles, and look, we know the angles are congruent. That one, those are corresponding and congruent. Those are corresponding and congruent. Those are corresponding and congruent. So that means that the third one is my correct answer. Angles stay the same, sides are different. Okay, now this one, guys, can be a little tricky. We're trying to identify which ones are similar. So again, it says rectangles. So rectangles takes care of those 90-degree angles. So angles are good. We don't need to worry about angles. What we do need to worry about is proportional sides. So we are going to make proportions, and we're going to compare them. All right. So this one can be tricky because I want you to notice where do they try and trick us? They try and trick us with this one. You guys notice how the longer side, the side that looks longer is actually 7, and the side that looks shorter is 9. Now, I don't know if that was a mistake in how they made this thing, but we have to take that into account. So I'm going to go and highlight all the short sides. So 6 is shorter than 10. 7 is shorter than 9. 3 is shorter than 4. And 3.75 is shorter than 5. This is going to help us match up for the proportions. Okay. 10 is the longer side in this one. 9 is the longer in this one. 4 is the longer in this one, and 5 is the longer in this one. So now I've marked my long and short sides to help me make proportions, okay? Now I'm going to make a proportion for each of the triangles. So I'm going to make a proportion for 1, for 2, for 3, and for 4, and then we're going to compare them. So let's go ahead and make my proportion for 1. I'm going to do yellow divided by blue. So that's going to be 6 divided by 10. That came from 6 divided by 10. For number 2, I'm going to go 7 divided by 9. So that's 7 divided by 9. For number 3, it's going to be 3 divided by 4. So that's 3 divided by 4. And for number 4, it's going to be 3.75 divided by 5. So 3.75 divided by 5. Cool. All right, now I've just got to grab my calculator and do all of these. So we'll open up the calculator. Oh man, calculator, you're too big. Can we do basic? Standard. Oh, still too big. Oh my gosh. Go back to scientific, I suppose. We'll move it over here. No, it won't let me. So I want to be able to see these. Oh my gosh. Guys. I can't do that either. This is the worst thing that's ever happened. 6 divided by 10. 6 divided by 10 equals 0.6. 7 divided by 9. 7 divided by 9 equals 0.77. Actually, I think it was 0.78. 3 divided by 4 is going to be 0.75. Yep. 0.75. And 3.75 divided by 5. 3.75 divided by 5 equals 0.75. Now, I want to look and see which ones match. All right. At this point, hopefully it's getting a little obvious. 0.75. Oh my gosh, I forgot to write the 5. Whew. 0.75 and 0.75 match, which means that 3 and 4 are my matches, which means that this is my correct answer. Now, I do want to point this out about 3 and 4, is that if I were to do yellow divided by yellow, so if I did 3.75 divided by 3, and I did 5, or blue divided by blue, so I did 5 divided by 4. You'll see that if we make the proportions between the two triangles, it'll actually still work. So let's do 3.75 divided by 3, 1.25. And then let's do 5 divided by 4. 5 divided by 4, 1.25. So you can see that I actually still make the same proportions, whether I make my fractions within the same triangle or between the two triangles. Okay, that's a lot. Hopefully we're feeling okay about this. Please go do the try it problems now, and hopefully we have some questions we can talk through next time we're in class. All right, have a great day. Bye.